Good morning friends. So I welcome you all for my video sessions. So past few days, so many classes we have discussed about matrices, different concepts of the matrices, right? So today and in previous class we have finished exercise 3.2. The second exercise is finished. So the next topic according to your book or syllabus is transpose of a matrix. Okay. So what do you mean by transpose of a matrix? So if I want to speak in general way, in simplified way, transpose means interchanging the rows and column. Whatever elements are there in column, they will become the elements of row. Whatever elements are there in the row, they become the elements of column. So what does the definition say about this is, for any matrix A, Aij, this is general representation of any matrix, for any matrix A, Aij of order m cross n. What is the order here? M cross n. M is the number of rows and n is the number of columns. Then transpose of the matrix A, transpose of this matrix A is obtained by interchanging the rows and column. If you interchange the rows and column of this matrix A, then you will get the transpose of this matrix A, right? Or if you want to get the transpose of this matrix, you need to interchange rows and column. Row should become column and column should become row. Okay, interchanging the rows and columns of the matrix, and it is denoted by what? A dash or A transpose, T at the power, A dash or A transpose. If suppose A is equal to Aij, what is I here? Represents the row. What is J? Represents the column, right? So M cross N, then what will be A transpose? A transpose or A dash will be equal to Aj. We should interchange rows and column. If we interchange rows and column, what will be the order? Initially it is M cross N, now it becomes N cross M, because whatever is there row here, that has become column here. Whatever column we are having here, that has become row. So rows and column will be interchanged. So the order of this matrix transpose of A will be N cross M. For example, you take an order. You've taken a matrix 4, 7, 3, 2, 9, 8. What is the order of this? 3 cross 2. 3 rows and 2 column. So 3 cross 2. Next, what will be A transpose? Whatever elements are there in the row, you put them as column. First row will become first column. Second row becomes second column. Third row becomes third column. So rows should be converted into column. What is first row here? 4, 7. That should become first column. What is second row? 3, 2. That should become second column. What is third row? 9, 8. That should become third column. Right? So here 3 cross 2. What is the order of this? 2 row and 3 column. So it is 2 cross 3. So you can see if it is 3 cross 2, the order will be 2 cross 3. So that is why it is said that if it is M cross N here, it will be N cross M. So if I speak about one more example, so 1, 4, 7, 6, 9, 2, 1, 5. This is of order 2 cross 4, right? So A transpose means what? Taking the transpose, interchanging rows and column. So first row will become first column here. What is first row? 1, 4, 7, 6. So 1, 4, 7, 6. You should write in the form of column. Next, what is second row here? 9, 2, 1, 5. So it becomes second column. So it is order of this 4 cross 2. So there it is 2 cross 4. Here it is 4 cross 2. Okay. So transpose means interchanging rows and column. Right. So if it is there in this way, transpose will be this. Right. So if the matrix is in this horizontal position, transpose will be in the vertical position. If the matrix is there in the vertical position, transpose will be in the horizontal position. So I hope you have understood this one. Now pause the video and make a note of this. Okay friends, I hope you have taken down the things which were there in the previous slide. So in previous slide we have seen what is the transpose of a matrix, its definition and an example for that. So let's proceed with the properties of transpose of the matrix. This is a very simple property there, right? So we are having four properties. if A and B are any two matrices of suitable order. What do you mean by suitable order? See, transpose, when we take transpose and we have certain properties, to prove those properties the matrices should be of required order. That is nothing but suitable order. If you are implying addition property, then matrices should be of same order. If you are going for multiplicative property, then number of column of the first matrix should be equal to number of row of the second matrix. So that is what the meaning of suitable order is, right? So for any matrix A and B of suitable order, what we have here is A transpose of transpose, right? A transpose of transpose, or transpose of A transpose. Transpose of A transpose is equal to A. So what do you mean by transpose? Interchanging the rows and column. So if you interchange rows and columns of A, then A become A transpose, right? So transpose of that A transpose will be equal to A. That we will see with some example, right? Second one is K into A whole transpose is equal to K into A transpose, where K is a constant here, right? When K is constant, this is nothing but scalar multiplication. K into A will be scalar multiplication. So K into A whole transpose will be equal to K into A transpose, right? Which is very important is K should be a constant. If K is constant, then only K into A whole transpose will be equal to K into A transpose. Third, A plus B whole transpose. A plus B whole transpose will be equal to A transpose plus B transpose. And finally, A into B whole transpose is equal to B transpose into A transpose. Remember this property, A into B whole transpose is equal to B transpose into A transpose. When it was addition, A plus B transpose is equal to A transpose plus B transpose. But when it is multiplication, A into B whole transpose is equal to B transpose into A transpose. That is, A into B whole transpose is B transpose into A transpose. These are the four properties of transpose of any matrix. Let us take an example. Okay. So what is A here? 2 cross 3 matrix. Right. So A is 2 cross 3 matrix. And B is what? It is also 2 cross 3 matrix. Then we should verify A transpose whole transpose is equal to A. That is property 1. Then we should verify property 2. That is K into B transpose is equal to K transpose. Nothing but the second property. And that is A plus B whole transpose is equal to A transpose. That is, we need to verify first, second and third. For this one we cannot verify fourth property. We cannot verify fourth property. Why? Because you cannot multiply A into B. You cannot multiply A into B, or you cannot multiply B into A also. Right? That is what we cannot verify fourth property. That is not possible. So we can verify first, second and third property. Right? Coming to first property, what is that? A transpose whole transpose should be proved as equal to A. So what I said, what is A transpose whole transpose? Transpose of A transpose. So let us explain that one. A is given 3 root 3 2 4 2 0. What will be A transpose? Converting rows into column and column into row. First row becomes first column here. Right? What is first row? 3 root 3 2. So it becomes the first column. 3 root 3 2. And what is second row? 4 2 0. So it becomes second column. 4 2 0. Now this is what? A transpose. Now A transpose whole transpose means we need to take transpose for this A transpose. We need to take transpose for this A transpose. So what is the property of transpose? What is the meaning of transpose? Rows should be converted into column. So now if I want to take transpose for this matrix, so first row will become first column, second row will become second column, third row will become third column. So the transpose of this matrix will be, first row is what? 3 4. So it becomes first column. Second row is 3 2. So it becomes, root 3 2. It becomes second column, root 3 2. Third row is 2 0. So it becomes third column, 2 0. Is it not equal to A here? You check. Definitely it is A. Right? So if you take transpose of A transpose, you will get the value of A. So first property is verified. What is second one? They have asked us to verify A plus B whole transpose is equal to A transpose plus B transpose. Let us take out LHS and RHS separately and prove that it is equal to, both are equal, right? So A plus B means what? A is given root 3 root 3 to 4 to 0, and B is 2 minus 1 to 1 to 4. I have written down here. A plus B means 3 plus 2 5, root 3 minus 1, 2 plus 2 is 4, 4 plus 1 5, 2 plus 2 4, 0 plus 4 4, right? So this is what? A plus B. A plus B transpose. So convert row of this column and row of this into column, right? Row should be written as column. So when I take transpose for this, what is first row here? 5 root 3 minus 1 4. So that becomes first column, 5 root 3 minus 1 4. What is second row here? 5 4 4. So that becomes second column, 5 4 4. So what is the value of A plus B whole transpose? That is 5 root 3 minus 1 4 4 4. This is what? A plus B whole transpose. Mark it as equation 1. So this is LHS part. Now we need to find out RHS part and prove that they are same. A transpose plus B transpose. If I want to add A transpose and B transpose, first I should know the value of A transpose and B transpose. A is given, what will be A transpose? Row should be converted into column. So first row becomes first column. So A transpose, first row is what here? 3 root 3 2. So what will be first column? 3 root 3 2. What is second row of A here? 4 2 0. So when I take transpose, it becomes second column, that is 4 2 0. So what is A transpose here? 3 4 root 3 2 2 0. So transpose is nothing but writing down rows as column and columns as row. Okay. So B is given here. What is B transpose? First row will become first column, second row will become second column. So 2 minus 1 2. It is 2 minus 1 2. First row has become first column there. Second row 1 2 minus 4. 1 2 plus 4. So it becomes second column. 1 2 plus 4. Okay. So we have the value of A transpose and B transpose, right? So what will be A transpose plus B transpose? Add both the matrix. 3 plus 2 is, so you write down initially, what is 3 plus 2? 5. 4 plus 1, 5. Root 3 plus of minus 1, that is root 3 minus 1. 2 plus 2 is 4. Here 2 plus 2 is 4 and 0 plus 4 is 4. So what you get here is 5 root 3 minus 1 4 and 4 4, right? So if you consider this equation 2, this forms the RHS part of the equation, that is A transpose plus B transpose. Now check equation 1 and 2. By equating 1 and 2, by comparing 1 and 2, you can find that equation 1 is equal to equation 2. So nothing but A plus B whole transpose is equal to A transpose plus B transpose. So we have verified second one. So what is left is third part. So what should be proved here? K into B whole transpose is equal to K into B transpose, where K is a constant. So what you do here is, you try that as your homework. So what you should do here is, for this matrix you multiply K. Perform the scalar matrix multiplication for this particular matrix. Then you will get what? K into B. You will get K into B. What is there in the bracket? That will be a matrix. K into B will be a matrix. Take transpose of that, then you will get the LHS part. Right? Mark it as equation 1. Now coming to RHS part. We are having B here. Take B transpose. It will be a matrix. B transpose also will be a matrix. Now multiply K for that B transpose. Multiply K for that B transpose. Then that becomes K into B transpose. Mark it as equation 2. Now compare equation 1 with equation 2. Compare equation 1 with equation 2. You will find that both are equal. They should be equal because that is the property there. Okay. So what you do is, you pause this video, take these notes down and also try that problem at your home. Okay. So take it down. Okay friends, I hope last example is clear for you, right? So we'll proceed with the second example. In previous example, we were not able to prove the last property, that was A into B whole dash is equal to B dash A dash, because the orders there were not suitable for matrix multiplication. They were only suitable for matrix addition but not for matrix multiplication. So A into B whole dash involves matrix multiplication, so it was not possible there. So let us prove that property with this example. Here we have a matrix A which is 3 cross 1 matrix, and here we have a matrix B which is 1 cross 3 matrix, right? So 3 row and 1 column, so 3 cross 1, so 1 row and 3 columns, so it is 1 cross 3. So the orders are suitable for matrix multiplication. So we can verify AB whole dash is equal to B dash into A dash. So what is AB whole dash? Multiply A into B, so you will get one matrix. Take transpose of that matrix, right? So A into B whole dash. In bracket I have mentioned matrix A and matrix B, and I have taken the transpose, right? So what is multiplication of this? So each row should be multiplied with each column. First row with first column, second column, third column. Second row with first, second and third column. Third row with first, second and third column. First row with first column. Minus 2 into plus 1. That is minus 2. So first row into first column is minus 2. First row into second column. Minus 2 into 3. Minus 6. Next, first row into third column. Minus 12. Then second row into first column. 4 into 1. 4. Second row into second column. 4 into 3. 12. Now second row into third column. 4 into 6. 24. Right. Next, third row into first column. 5 into 1. 5. 5 into 3. That is third row with second column. 5 into 3 is 15. Next, third row with third column. 5 into 6 is 30. And transpose as it is. So now this is A into B. What we want? A into B whole transpose. So we have to transpose here. So take transpose of this. First row becomes first column. So 2 minus 6 minus 12. This is first row. It becomes first column. 2 minus 6 minus 12. Second row becomes second column. 4, 12, 24. That comes in second column. 4, 12, 24. Third row becomes third column. So what is there in third row? 5, 15 and 30. So that will come in third row here. 5, 15 and 30. So this is what? A into B whole transpose. We got the LHS part of this. Now we need to prove RHS part. B transpose into A transpose. So to prove this B transpose, to find the value of B transpose into A transpose, we want B transpose as well as we need the value of A transpose also. So what is B transpose? B is a row matrix. If you take transpose, it becomes column matrix. Right? So 136 is in the row. So B transpose will be 136 as column. So 136 into, what is A transpose? A is a column matrix. So that becomes, A transpose becomes a row matrix. So A dash is minus 2, 4, 5. So B dash into A dash is 136 into minus 2, 4, 5. Now multiplication, first row into first column. What is there in first row? 1. First column we are having minus 2 as it is. First row into second column. 1 into 4, 4 as it is. First row into third column. 1 into 5 is 5. Now second row with first column. 3 into minus 2, minus 6. Second row into second column. 3 into 4 is 12. Second row into third column. 3 into 5 is 15. Okay. So second row is finished. Now let us come to third row. 6 into minus 2. Third row with first column. 6 into minus 2. Minus 12. Third row with second column. 6 into 4. 24. Third row with third column. 6 into 5. 30. So this is nothing but B transpose into A transpose. You can compare AB whole transpose and B transpose into A transpose. These two matrices. It is clear that both are one and the same. So I can write AB whole transpose is equal to B transpose into A transpose. So this is all about transpose of any matrix, right? And regarding the properties of those matrices. I hope the concepts are very much clear here, right? So if you understand the basic concept, then that is more than sufficient to understand all the problems here, because very simple, right? So this finishes the properties as well as transpose of the matrix. Now you can try these two problems as the work for your homeworks, right? So what is the transpose? You need to, in first question you need to find transpose of these three matrices. That is very simple. In second one, matrix A and matrix B are given. You need to verify all the properties of the transpose of matrix. There are 4 properties which are to be verified. Right? So with this, we'll wind up this session. So having any doubt, you comment your answer in the comment your doubt in the comment box. Also, the answers for this, so you can comment me the answers in the comment box. Okay? So we'll stop the video here. So in next session, we'll deal with symmetric and skew symmetric matrices. Right? We'll take the concept of symmetric and skew symmetric matrix. Right? So for this, we'll end up the session here. You can pause the video, take the notes down.